Welcome guys, good evening. So let me start my mapping. Okay. Okay, so let us continue now. It's the 9/7. So today we are going to start our topic of VPN. Okay, today we are going to understand what the VPN is, and mostly we will be covering the SSL and IPSec VPN. Okay, so the VPNs that we are going to cover here is with reference to the IPSec VPN. Okay, under which we will be taking care of site to site. Okay, we will be also dealing with the aggressive VPNs and all. Okay, or you can say it as if it's a dial-up VPN. Okay, so we will be dealing up with site to site and dial-up VPN. Okay. Dial-up VPNs, and the other VPN that we will be working with reference to is SSL VPN. Okay, and of course we will be also be dealing with the AD VPN. Okay, so okay, let me write it in a sequence that how we are going to cover. Okay, so like for example, we will be doing after the IPsec, we will cover the AD VPN. Okay, and then we will be going with the SSL VPN. Okay, so all these are the VPNs that has to be covered into this courses. Okay, we will not be talking about OC VPN. Okay, that is overlay. We will not be talking about that. Okay, we will only be discussing the IPsec site to site and dial-up and the AD VPN and the SSL VPN. That is what we are going to discuss. Now, I will try to break these VPNs into the simplest concept that there is. Okay, so in order to start with the VPNs, right, we have to first understand the basic terminology with reference to the VPNs that is there. So the first thing comes first, the challenge. Okay, that why do I need a VPN? So before I go into that, can I just get a quick view that is there anyone here who has not worked on VPN before? Is there anyone who has not worked on VPN? So that means everyone has worked on VPN before?
Yes, we have worked on.
Okay, fine. Then it's a good one. Okay, so I'm hoping really a good discussion and on to the VPNs. Okay. Okay, fine. So first things first, the challenge. Okay, it's like why I will need a VPN. So can I just get an just a quick single-handed? Why do you think that I need a VPN? Without VPN, can't I achieve a certain thing? Why there is a need for a VPN in the first place? Can anyone answer to that?
Yeah, VPN is a virtual private network. So it is required when any server that is running on our private IP address, okay, and we want to access that through public internet. In that case, we create the SSL VPN, and we access that like file server, and there are so many applications that are running only our intranet. So in that case, we also use the SSL VPN to access that applications through our public network. So we create the secure socket layer to access that application. And IPSec is also used to create a point-to-point tunnel between two devices. So it is also used to access the private network. So as per my understanding, it is used to access our private network through public environment, right?
Okay. So you are saying this, right? So for example, you have a server which is into your network, right? So let's say I have the FortiGate firewall, which is connected to the internet, right? ISP. So if let's say someone is working from home or someone is accessing from outside anywhere over the internet. So if this PC wants to reach to this server, you have to establish the SSL VPN in order to access the server, right?
Right.
That is what you meant. Okay, fine. So can't I achieve this without the VPN? See, you did it with the VPN, right? I will do it without the VPN. How? For example, your internal server IP is, let's say, 192.168.1.10, for example. Okay, and your FortiGate public IP here is 1.2.3.4. Okay, so what I will do is I will simply create a DNAT. I will say that, hey, look, if someone tries to reach to 1.2.3.4 on the port 443, okay, translate him to the IP 192.168.1.10 on the port 443, right? Now, if this PC tries to access https://1.2.3.4, so when his packet will be coming in there on the FortiGate firewall, it will have source IP as, let's say this PC public IP is, let's assume this PC public IP is 11.12.13.14. So source will be 11.12.13.14, destination will be 1.2.3.4, right? Correct? And since on the FortiGate firewall I have configured the DNAT, so 1.2.3.4 will be translated to 1.10, and hence after that the routing lookup will happen, which will send the packet to the server, right? So even without the VPN, I can access your internal server. So why do you want me to configure a VPN when I can just do the same thing with a single DNAT?
Actually, due to security reason, there are so many applications that that is running in intranet, not internet. In that case, we also require.
Okay, tell me the intranet application.
Like SAP application is running on
Okay,
intranet.
so so let's assume there is a SAP application, that means a SAP server or some sort of a database or anything. That application is hosted somewhere, right?
Yes.
You might be having a SAP server.
Yes.
So what is the SAP server? So the concept follows the same. Whatsoever you might be hosting here, I can access it from, just I need to create a DNAT. I can go with that.
Maybe in order to have the communication secure by doing the traffic encryption in order to maintain the confidentiality, and in order to someone should not tamper the data.
That's
Yeah.
fair. So the main motive behind the VPN is, the main reason why I need a VPN is, the issue was not with the connectivity or like reachability. The issue was not with that. I could have reached, like I showed you just an example that just as doing a single DNAT, I could have reached it. Okay, the issue is not with that. The issue was that although I am able to reach to a particular destination, but since I am going over the internet, hence my data is exposed, right? For an example, you might be accessing HTTPS, so there is an SSL handshake which will ensure that your data is somewhat safe and all right. But what if all the applications, there are a lot of protocols who do not use SSL? For an example, HTTP, right? Yes or no? There are a lot of other protocols which do not rely upon a secure socket layer handshake, SSL. What about those? Let me take an example. I want to take remote desktop of the server. For example, I want to take RDP access of the server. Now, RDP is a protocol or a service that runs on TCP port 3389, right? Does it perform any sort of any encryption? No. Yes or no? Right? So if from outside I am trying to take remote desktop of the server, for example, I'm just taking the same example, okay? So I am trying to take RDP access for 1.2.3.4. Now this IP will be translated. I can create another DNAT entry where I can say that, hey, look, if it is coming for this port now, send him to 192.168.1.10 to 3389. I can do this, not an issue. But the challenge here is that this time when the remote desktop connection is forming, I'm able to reach, but my communication is exposed. Since my traffic is going over the internet, hence anyone with the right tool can see what I'm sending, right? So the issue was with reference to confidentiality as well as security.
This data security is the main reason.
Yes, security. That was the whole concern. Okay, this is where the concept of VPN came into place. It said virtual private network. Okay, so VPN will help you to achieve this sort of a communication, as well as the VPN will also achieve, it's like help you to achieve the private to private communication over the internet. What do I mean by that? For example, you have a LAN setup here. The LAN IP is 192.168.1.0/24. For example, this is connected to a switch. This is connected to the FortiGate firewall here. Okay, this is then connected to the internet. And somewhere, some other location is also having a FortiGate firewall, which is connected to the switch and which is then connected to a different LAN. This LAN is nothing other than 10.10.10.0/24. Now these two are the private networks. So if I want to communicate between this LAN to here, I have to translate the IPs, right, to the public, because private IPs are not routable, correct?
Yes. Yes.
Even though we would be able to translate it, not an issue. I can translate it just like I did a DNAT. In this case, I will configure a source NAT. I will configure source NAT and I will send the packet out. It will receive it and it will then forward further. So never ever in any case the communication was an issue. It was not an issue. Reachability was not an issue. The issue was always about security. If this PC, if any system here is trying to take remote desktop or is trying to ping or is trying to exchange some information, maybe that is an SMTP. Maybe that's any simplest of the simplest protocol like remote desktops. Okay, pings, telnets. Now those things are not secure. So that's when the VPN came into picture. Okay. So VPN ensured that the private to private communication can happen directly, and that too in a secured manner over the internet. After all, VPN is formed over the internet, right? That's how the tunnel is formed, over the internet. Okay, so that the data can flow. Which data? Private networks data. That's why it's called virtual private network. Okay, mostly dealing with when you configure an IPSec VPN, you do not actually deal with the public to public. No, you always send the data which is from private network to a different private network. Yes or no? Right? So that is where the need of the VPN arises in order to secure the mode of communication. Now I am using a word, mode of communication. Okay, so it's not a necessity that, okay, I have a designated route so I can reach it to a certain point. Of course, you can reach, but is that route secured? Is that mode of communication secured? No, that's not. So you have to use a safest mode of secured communication. That's where the VPN is. Now, saying that, okay, see, in the VPN, you have two types of operations, or like two types of tunnels. Okay, so I will go with the IPSec first. I will not be touching the SSL VPN right now. Okay, so forget about SSL VPN. Whatever I'm going to say now is with reference to IPSec. Okay, whatever I'm going to say. Now, in the IPSec VPN, you have actually two modes of the IPSec VPN. What are those two modes? One is tunnel mode and the other one is transport mode, right? If I'm not wrong, this is what it is, tunnel mode and transport mode. Now, what is the difference between that? What is tunnel mode? What is transport mode? Where I should use what? The first question, where I should use what? Now, in order to understand, do I have to configure or do I have to use tunnel mode IPSec VPN, or do I have to use transport mode IPSec VPN? What I have to use? To understand that question or to know the answer of that, let us first know how do they behave. Okay, so for an example, let's say you have a data packet. Okay, so we will assume a simplest example. Okay, ICMP packet. Okay, so let's say we have a ICMP packet, so that packet will have a IP header and there will be some sort of data into it, right? Yes or no? So this is so this together is our actual packet, right? Our original data. This is our original packet that was sent from the PC. Whatsoever that PC is, let's assume this is how it is. That there is one PC connected FortiGate internet, and here is one more FortiGate, and here is one more PC. Okay, so the communication is between PC1 to PC2. So when the PC1 is trying to ping to PC2, and assume there is a VPN tunnel formed between these two firewalls. Okay, there is a VPN tunnel formed here. Okay, there is a VPN. Now assume if the data is sent from the PC1 to PC2, the PC1 will send data as one what? That this is the actual data, actual packet, right? Which will, it's a ping packet. So an IP header and some ICMP payload. Done. Now, if you are using tunnel mode, what will happen? Then the same data, okay, the actual packet will be there, IP and this data, and after that there will be the encapsulation. ESP header, ESP trailer, and ESP authentication. In short, it is encapsulated under the ESP headers. That's the major protocol. Actually, ESP and AH, there are two protocols that could have been used. Okay, that is being used under tunnel and transport mode. Okay, so whenever you want to send a data, it will be encapsulated because you want to save your data, right? You want to ensure that my data is safe. No one is able to see it, right? How you will do that? Encapsulate. See, the name is itself clear. Encapsulate, right? So just think of a capsule. If you open the capsule, the medicine is actually inside the capsule, right? So if you want to save something, you will put it into a capsule and like close it, right? So that's why we call it as encapsulation. Okay, so this was our actual data which we have encapsulated with the ESP header. Once we have done with that, then a new IP header will be added. A new IP header will be added. And this is how the packet is sent. Now let me take an example of this that will start making much more sense. Now assume this PC had the IP of 192.1 and this PC had the IP of 10.1. Okay, the public IP for this firewall is 1.1 and the public IP for this firewall is 2.2, for example. Okay, so you start with the VPN between 1.1 and 2.2 because they are the public IPs. Okay, now, so that means when the actual packet will be sent, the IP header will look like this. That hey, source is, what is source? When PC1 will try to send to PC2, what will be the source? Source will be 192.1. Destination will be 10.1.
10.1.
This is what the IP header will look like, and then you will have a data. Correct? Yes or no?
Yes.
Okay. Now, I told you if you use tunnel mode, what will happen? This actual thing will be encapsulated. Okay. So actually, how this is going to look with reference to this side, it will look like this. So your actual data 192.1, 10.1, the actual packet, I'm using the word actually data. It is actually the actual packet. Okay. So this is the thing that was there. So now it will be encapsulated with the ESP. Okay. ESP.
Yes.
Okay. And then a new IP header will be added here. What will be the new IP header? 1.1, 2.2. Okay. So when the packet will be sent, no one will be able to see this thing. Okay. You will not be able to see this part. This part. You will not be able to see that. Because this is encapsulated into the ESP header. So the packet will move with reference to the new IP header. That means the public IPs actually. Whatever the public IPs is there, na, it will use those as a new IP header. Clear?
Yes.
Okay, so this is with reference to the tunnel mode. This happens when you are operating under the tunnel mode. But if you have the transport mode, then what? So I will take the same example, original packet. So you have the original packet. So here what happens is, you have the data. Now your data is actually encapsulated with the ESP header. And the actual IP header is here. So there is no new IP header. So how, so with reference to the data packet, how it will look? It will look like this. That you have a data. You have the ESPs here. Here also ESP authentication. And this will contain the actual IP header. That means 192.1 and 10.1. Clear? Seeing the difference? So here only your data is encapsulated. The complete packet is not encapsulated. Only data is encapsulated. In which mode? Transport mode. Now the question comes. Okay, fine. Where I should use what? See, if you have a indirect connectivity, again I'm repeating, if you have a indirect connectivity between two private networks. For example, let's take an example. Like in this case, you have a PC connected to the FortiGate 1 connected. Let's say this is also FortiGate 1. Okay, so here you have an internet, and here you have a different FortiGate 2, and here you have a different PC. Okay, so this IP is 192.1, this IP is 10.1. So since you have two private networks indirectly connected, right, over the internet, right? In this case, you will always use what? Tunnel mode. Why? Because see, when the new IP header is added, what is added? Actually, the public IPs are added, right? And you know that in order to cross the packet over the internet, what you need? Public IPs can only cross, right? Private IPs cannot. So if you use transport mode, in that case, when the PC will say that the source IP is 192.1, destination IP is 10.1, so do you think that this packet can travel over the internet? It cannot, right? And whenever you have a directly connected networks, that is where you will use transport mode. Now you will say, hey, where I will have a directly connected network? That network is called MPLS. Okay, so if you have a MPLS kind of a setup, there you can use transport mode, because MPLS is what? The private networks. It's an interconnectivity of a private networks, right? So even if you send a packet like this, the next hop will know how to reach to the other hop. Okay, 10.1, how we can reach to the other private IP. That's the MPLS used for. So if you have such a setup, then go with the transport mode, else go with the tunnel mode. That's why you might have seen mostly you work with the tunnel mode, mostly, always. Why? Because of this reason. And also because the tunnel mode is the one who actually encapsulate your complete packet. The complete packet is encapsulated, right? It's not only the data, but the entire thing. Correct? Okay, so this is what you want actually, that when I'm sending some information over the internet, it should actually be hidden. Okay, so clear with this point? Any doubts, questions?
Clear.
Okay, fine. So those were two modes. Now, with reference to IPv1, okay, sorry, I'm saying IPv1, okay, so the IPsec, okay, with reference to the IPsec VPN, the IPsec is the protocol that is being used. Actually, the protocol that is used is ISAC, Internet Security Association Key Management Protocol. That's the full form of ISAC. Okay, and IK is nothing but Internet Key Exchange. Okay, so actually you can configure the IPsec to use either IKE v1 or IKE v2. There are two versions of IKE protocol. You can use any of that. Okay, so which one is the best, which one is the good, or which one you should use? You can use any of that. Okay, you can go with the IKE v1, you can go with the IKE v2, but IKE v2 is much quicker and do not involves a lot of things. Okay, but do not worry about IKE v2. Okay, we will focus on IKE v1. If you know IKE v1, you know IKE v2. Okay, we will not learn lot of things. We will learn only one thing, and that one thing is enough to complete the entire IPSec VPN. Okay, so here we are simply going to focus on IKE v1. After all, once the IKE v1 is completed, I will tell you about IKE v2 as well, and you will find it that it's the same. Okay, Now see, in terms of IPE V1, okay, the IPSec has three kinds of a VPN actually, three types of VPN in the IPSec V1, okay. For the IPSec V1, you have three types of VPN actually. One is site to site VPN. Other one is dial-up VPN. For me, it's only two. Okay. You may find someone saying that, hey, you can also have a third one, which is like dynamic VPN. Okay, dynamic VPNs or something to that they will use. Okay, so I will not, I'm not going to use all these terms. We only have two VPNs, site to site and dial-up VPN in IPSec. I will cover all the things. Okay, let us focus on a single point. Now, the question is, hey, whenever someone asks me to deploy a VPN or to configure a VPN, okay, I'm actually not sure. I know that I have to configure a VPN, but I'm not sure what type of VPN I have to configure. Do I have to configure dial-up VPN? Do I have to configure site-to-site VPN? Or do I have to configure like dynamic VPNs or something like that? What kind of a VPN, IPSec VPN shall I configure? Right? And where I should configure what? So to understand that, let us simply discuss the types of network that we might be getting in order to configure the VPN. Okay, let us discuss that thoroughly. I will take a new page. Now let us see. Let's say the first thing, okay, the first scenario. The first scenario is you are having a LAN network which is connected to a switch, which is then connected to what? Let's say, okay, this is not going to remove, right? Okay, I have to write something below. Okay, so let us take an one LAN talking to a switch. Switch is talking to the FortiGate firewall. I will call it a FortiGate 1. Okay. FortiGate firewall is talking to the ISP. ISP is again connected to some different location, FortiGate 2, right? And he is again talking to a switch, and in turn he is also talking to a LAN switch. First scenario, this can be the case, right? Now let's assume the IP, the public IP of this FortiGate 1 and public IP of this FortiGate 2 is fixed. Okay, they are static IPs. Okay, so like assume it is 1.1.1.1 and this is 2.2. Come on, 2.2.2.2. Okay, that is what it is. Fixed IPs. You may be dealing with such a situation or such a setup where you want to configure the VPNs. Both the sites are having a fixed IPs. Okay.
Yes.
Second scenario, you may land up in a certain situation where, like LAN is connected to a switch. Switch is connected to the FortiGate 1. Okay. FortiGate 1 is connected to the ISP. The same thing. ISP is connected to the FortiGate 2. FortiGate 2 is again connected to a switch, and switch is connected to a LAN 2. This time, assume FortiGate 1 has a fixed IP 1.1.1.1, but FortiGate 2 IP is changing. Okay, it's not fixed, it's dynamic. It's dynamic, something which is keep on changing. There is no fix, right? Today it is 2.2.2. After a reboot, it may have 3.3.3.3. any of the public IPs that can be there. It's not in a static one. Fine. Okay. Third situation. LAN switch. FortiGate 1. ISP. FortiGate 2. Switch. LAN 2. Assume FortiGate 1 has dynamic IPs. Not sure what the IP is there. It can keep on changing. FortiGate 2 also has dynamic IP. I'm not sure what is going to be there, right? That can also happen. Yes or no? Fourth situation. LAN switch FortiGate 1 ISP. Now here I'm not sure who is on the other side. That can be a PC, that can be any phone, that can be any firewall, that can be any router. Correct? Unknown. Fifth situation. LAN switch FortiGate 1 ISP router FortiGate 2 switch LAN 2. This can also happen. Is it necessary that you will be talking to the FortiGate, like the ISP link will be connected to the FortiGate 2 only, right? That's not necessary. Right?
Yes.
Any other situations that you can think of? Any ideas?
Router on both sides.
Router on both sides, okay, fine. LAN switch FortiGate 1 router ISP again router. I will call it as router 1 and router 2. FortiGate 2 switch LAN 2. Clear? Fine. You guys have worked on VPNs, right? Tell me any other situation or any other setup that you might have seen which would have where you might have done the configurations. These are the situations that you will be coming across if you have to set up a VPN.
Yes.
Okay. Now let us discuss one by one. Okay. Before we go into that, okay, before I start discussing this, I want to have a clarity on few of the terms. Okay. Like for example, I used the term static. I use the term dynamic. Okay. Static means what? The IP is constant. Right? Dynamic means IP is changing. It's not constant. For example, triple PoE link or DSCP based links. Right? Mostly dealing with the triple PoE link, because if you are on the ISPs, yes, you will be dealing with that triple PoE link. Right? Now, tell me one thing. If you have to, if there is an IP, for example, Have you seen any such situation that where the IP is something that is hard to track, but you still end up accessing that server? That server may have multiple IPs. That server may currently be hosted at 1.1.1. Maybe after half an hour, 8, you will see that the same server is showing you the IP 2.2, 2.2, right? But still you are able to access the server whenever you want. Have you seen any such a situation? Because that is the same logic that we are going to use here. Have you seen anything like that? Where the server IP keeps on changing, but still you are able to access that server? Have you come across such a thing?
No.
Anyone has not seen that? No one has seen that. That's weird. Okay, fine. Let me show you that. What is that? Everyone has seen that. How many IPs does Google server has? Do you think Google has only a single IP?
No.
What is Google? Google is a server, right?
Yes.
It has multiple IPs?
Yes.
But still you are able to access Google server. How? Because of the domain name?
Domain name.
Because you do not care what the IP there is. You are simply accessing google.com.
Correct. Yes.
So in short, can I say that whenever there is no certainty of the IPs, that I am not sure what the IP that device or that server will be holding, then but still I want to establish the connection. So what is the only way that I should have domain? You have to host that device with reference to a domain, right? So similar with the same concept of Google, if someone is saying that my FortiGate firewall public IP is not constant, it is changing, it is dynamic, it is changing, but I want the access of FortiGate firewall. So how I can do that? That means I have to host a domain for the FortiGate firewall. I will say xyz.fgt.fddns.com. This is the domain. So you do not worry what the IP there is. You simply have to do what? You have to simply access xyz.fgt.fddns.com, right? Enough. Just like you access google.com. This domain name will automatically resolve to the latest IP that is assigned to your FortiGate firewall by the ISP, right? After all, what is that the Google is getting you? DNS resolution. What is the current IP of the Google server in your region? Who is telling you? DNS, no? The records of DNS is getting updated, right? That, okay, yesterday maybe the IP was different. Now the IP is this, right? So your browser, when you access google.com, you are not worried. You are simply sending a DNS query message. You are getting a DNS response. You are getting that IP, sending the message, right? Done. Google access done. Correct? Yes or no?
Yes.
So on the FortiGate firewall also the same approach, nothing different. Whenever the IP is not constant, you will configure a thing called DDNS.
So Ron, where we need to do the host entry?
No host entries. Allow me to complete. Okay. So
okay.
DDNS. So DDNS means the first D stands for dynamic DNS. So firewall, so what you will do is DDNS is actually when you enable the DNS on the FortiGate firewall and you decide your domain, whatever the domain that you want to choose, you choose it and give your name. Okay, you can form your own website kind of a thing. Okay, you choose it, like I've told it as xyz.fgt.fdns. Okay, you call it anything that you want. Okay, so what will happen now? Firewall will check with the FortiGuard. Okay, there is a DDNS service or there is a dedicated DDNS server that is on the FortiGuard cloud. Okay, once you create your domain name, okay, your firewall constantly sync. Okay, as soon as the IP will change or not change, it constantly sends its own status that, hey, this domain is currently has to be resolved to this public IP. Okay, your firewall will be sending it to whom? DDNS server constantly. So your DDNS will be aware of that, and that FortiGuard DDNS will ensure that that record is pushed to the entire DNS, no matter which DNS server you using except the internal one. If you are using something which is globally, okay, you will get it. Just like you get for google.com. No matter you use a DNS as 8.8.8 IP or you might be using any other DNS server, you end up resolving the Google IP, yes or no? In the same manner. So it's the responsibility of the DDNS to update the A record. I believe everyone knows what the DNS A record is. A record is the record which maintains the record of domain to the IP, right? Okay, IPv4 addresses. So it will take care of that. You don't have to worry. Only thing you have to do is configure the DDNS in such a case. So whenever your firewall, to summarize what I've just told you in a single line, the concept is if your firewall public IP is not constant and has a tendency to keep changing, then you have to configure or set up DDNS onto your FortiGate firewall. How you will configure the DDNS? You have to go in network, DNS, and under that you will see the FortiDDNS. Here I have an unlicensed firewall, so I cannot show you that. That option is not visible to me. But if any one of you have a licensed firewall, if you're willing to share, I can show you. There is a DDNS. I'm just stopping the screen share.
Yes.
Yeah, turn it on. Thank you. Okay, so that's how you have to configure the FortiDDNS. Okay. Now, I'm again starting sharing my screen. Okay, so see here. So going back to this. So if in case your IP is not constant, you have to configure the DDNS. Why? Because after all, you want to take the access of the firewall, right? So that's why you have to get with the domain name of the firewall. Fine. Now, see, I will also be using two terms. Okay, I will also be using two terms. The terms are local IP or local subnet, you call it, and remote IP or remote subnet, you call it. Okay, now what this local IP and local subnet means, and what does remote IP and remote subnet means? Whenever you will decide that what is the local IP or what is the local subnet, you always have to look with respect to the firewall on which you are working. What is local to me, that is remote for you. And what is remote for you, that is local for you. Clear? Okay. So you always, whenever you have to take a call that, hey, what is my local IP? What is the local subnet? What is the remote IP? What is the remote subnet? Always think that question with reference to the device on which you are going to configure the VPN. If you are going to work on firewall number 1, think with reference to firewall number 1, that as per firewall number 1, which is my local subnet and which is my remote subnet. Okay. Similarly, I will also be using the certain words like local gateway, remote gateway. Same concept. You always have to decide this with reference to the firewall that you are working on. Okay, that is what you have to decide. Clear? Now, with that understanding of these keywords, let us now move to our scenarios. First scenario. In first scenario, FortiGate 1 and FortiGate 2, if you have, that means, let's say I am the engineer who is working on FortiGate 1. I have to configure the VPN. So that means what I need? I need the information of the other side. First information what I need, that what is the IP of the remote firewall. I'm using the term now, remote. So if I am an engineer who is working on FortiGate 1, so for me, who is remote? FortiGate 2. Okay, the other end. So I am saying, what is the IP of FortiGate 2? So see, there are few legitimate questions that you have to ask. Okay, what are those? First question, what is the remote IP or remote gateway, I would say. Okay, remote gateway IP. Okay, or in short, peer IP. First question is this. Question number B, is that IP of peer static or dynamic? That means, is it constant? Is it not going to change in future, or it has a potential to change in future if a device reboots or link flaps? Okay, so if a link goes down and up, will that IP change? Or if the device goes into a reboot state, will that IP change? That's the question. I need these two things. And third, no, I think these two questions will be fine enough. Okay, the first question will answer that what I was thinking as in third. So first question is enough. If you know these two questions now, if you give me the answer of these two questions, I can configure any VPN on any setup, on any topology. Just give me these two answers. How? Let us take the first answer. In the first scenario, scenario number 1. First question, what is the remote gateway IP? We will assume that we are the FortiGate 1 engineers. Okay. So the first question, what is the remote gateway IP? 2.2.2.2. So that means the answer is that you know the remote gateway IP. Then if you know the remote gateway IP, then the next question is there, right? That is that IP static or is that IP changing, dynamic? If the answer is that no, the IP is static, that means on the FortiGate Firewall 1, you will set up site-to-site VPN, that too with the static remote gateway. Come on, man. Okay, site-to-site as a static gateway, you will configure on the FortiGate 1 because you know the IP of the peer which is static. That's why the gateway that will be used here is static gateway. Right? Site-to-site communication. What does the word site means? Site means branches. Like Delhi to Bangalore. One office is in Delhi, other office is in Bangalore. So that means Delhi is one site, Bangalore is another site. So the engineers who are sitting In Bangalore, they are trying to reach to the engineers who are sitting in Delhi. Site-to-site communication. Clear? Now, if you are working on FortiGate 2 firewall, let's say you are an engineer who is also working on FortiGate 2 firewall. So with reference to FortiGate 2 firewall, the same question. What is the remote gateway IP? You got the answer 1.1.1, right? Is that IP static or dynamic? That IP is static. Okay, that means I have to configure site to site where the gateway is going to be static. Clear? VPN configured? Now, second scenario. Again, FortiGate 1. Let's assume we are the engineers working on FortiGate 1. Same question. What is the remote gateway IP? I cannot tell you that. Why? Because hey, that IP keeps on changing. So is that IP of the peer static or dynamic? It's dynamic. Okay. Then that means if it's the IP of a dynamic, that means you might have configured the DDNS onto the FortiGate 2. That means you have a domain. So you are saying me that, hey, I cannot give you the IP. I can give you the domain. Okay, fine. Give me a domain. If you give me a domain, then I will configure site to site where my gateway will be dynamic gateway. That is domain. After all, it's a site to site only, right? I'm going to reach to a particular destination, right? I know the destination. The destination is not an IP, but it's a domain name, like xyz.40ddns.com. But it's a destination that I can reach to, right? xyz.40ddns.com. It's a destination. That means I can go with that site to site. If I know the other side, I will always configure site to site. My gateway is changing. This time I'm not doing a static gateway. I'm going with a dynamic gateway. Okay. Let's assume we are the firewall 2 engineers. Now if I'm working on firewall 2, my question is, hey, what is the remote peer IP or remote gateway IP? I'm getting the answer. It's 1.1.1. Is that the static or dynamic? Will it change in future? No, it is a static IP. Okay, that means I will configure site to site, which will have a static gateway configured on the FortiGate 2. See the difference? How easy it is to decide where you have to configure what? Similarly, let us discuss scenario number 3. FortiGate 1. I am the engineer on the FortiGate 1. Hey, what is the peer remote gateway IP? The IP keeps on changing, so I cannot answer that. I can give you the domain name. Okay, fine. That means I will configure, you are giving a domain name, right? So I will be configuring site to site dynamic gateway here. Similarly to that, FortiGate 2. Hey, what is the peer IP? FortiGate 1 is also saying, I cannot give you an IP because my IP keeps on changing. So I have a domain, I can give you that. Okay, fine. Then on FortiGate 2, we will be configuring site to site with the dynamic gateway. Okay, this is what we will be configuring on the FortiGate 2 for scenario number 3. Scenario number 4. I will come to scenario number 4 later on. Okay. Or okay, let me talk about scenario number 4. I will come to 5 and 6 later on. Okay. Okay. Let us talk about scenario number 4. So here it is saying that, okay, let's say I'm working on FortiGate number 1. Okay. So on FortiGate number 1, the same question. Hey, what is the remote gateway IP? I don't know. You don't know means what? I'm not sure who is on the other side. Anyone can come and form the VPN. Okay. So if you are not sure who is on the other side, can you form a site-to-site tunnel? No. what you can form? Dial-up. Dial-up VPN. You will always configure dial-up VPN on a device, okay, from where you are not sure who is going to form the connection with. Like for example here, maybe the PC will try, maybe some phones will try, maybe some laptops may try, right? Maybe there is a router, maybe there is a firewall. Anyone can come out of this, right? I'm not sure. So in this case, always the connection will be coming towards you. Never ever on any device that you configure a dial-up, he will never initiate the connection. Now see, I'm using a term initiate. So since I've used that term, so I will try to bring up one more term, like terminology. That terminology is initiator and responder. Initiator means the one who will initiate the VPN connection. Initiates the first packet, whosoever will be sending, that is the initiator. And whosoever is going to respond to this first packet, that will be responder. Okay. So in those situations, in first to third, anyone can send, right? FortiGate 1 can also send the first message, or maybe FortiGate 2 can also start VPN, right? Similarly with any of the three situations. But in situation number 4, the FortiGate 1 cannot start the connection. Why? Because have we given him the IP that with whom he has to talk to? No. We have not defined the remote gateway there, no? The remote gateway is set for dial-up. That means anyone. Anyone can dial to you, man. But you cannot reach anyone. Why? Because there is no specific IP that you can reach to. Hence, FortiGate 1 in this situation number 4 will never initiate the VPN. Always it will wait for someone to send him the first message so that he can start responding. Okay? I will come to this situation number 5 and 6 later on. But is this first 4 clear? Where to configure what?
Yes.
Yes.
Okay, so no matter which topology you are working on, no matter how big the topology diagram that they give you, okay, simplify it in your mind.
Rohan, I
Just
have a
have the, yes please, yeah.
if we use the 2 ISP at FortiGate 1, okay.
2 ISP, huh, okay.
So in that case, we have 2 public IP, right?
So form 2 VPNs.
And other side, there is only 1 ISP and 1 public IP.
You have a single ISP, that means only 1 public IP. Okay, fine then.
And
How?
in that case, can we create a 2 VPN tunnel with 2 different ISP?
Yes, you can.
And the remote will be remain same. Remote IP will be remain same
Yes,
for both.
remote IP will remain same.
But in when we tried that one, the message display duplicate.
Why? Let me tell you why. Because you didn't identify it. Okay, so the firewall got confused there. Since the remote gateway was same. Okay.
Yes.
So you have to ensure that the negotiation parameters are different. Something should be different. Okay. So negotiation parameters should be different in that case.
So it means for if we have a remote IP 1, in that case we can create only one point side to side VPN tunnel.
No man. No. You can create as many as you want. Not an issue. I will tell you, okay?
Okay.
The thing is now you have to ensure that the negotiation is, just a moment, let me just put Okay, so you have to just ensure that it's like something should be different. If you have the same IPs, ensure that the phase one parameters are different. Okay, so that there is a difference between these two tunnels. If you say that the IP is also going to be same, the remote gateway is going to be same, negotiation parameters are going to be the same, then the firewall will be confused. That hey,
Okay.
then I have to send with the first VPN or like second one, right? Because both are going to the same point, right? So something should be different there. If you just try to change any phase one parameter, man, okay, you will see we even have no like duplicacy will be pointed to it. Okay?
Okay.
Fine. So that was ahead of that. I have not yet come to the negotiation part, but with these situations to get an understanding what you should configure, where and why, is it clear now? Always ask these two questions, man. This is important. If you know your remote side, you have to configure side to side, nothing else. Okay, if you know your remote side, configure side to side. If you do not know your remote side, dial. Simple. Simple. Okay. Now, coming to the next part. Okay. Since we are clear with this, I will be holding this situation number 5 and 6, scenario number 5 and 6 for now. I will come to this. I will come back to this later on. Currently, let us see to the VPN's negotiations now. We were on to the IPSec VPN 1, right? IPSec V1, that is what we are discussing about. Here we have two modes of operation in IP1. What are those two modes? Main mode and aggressive mode. Now, main mode is used for side to side, aggressive mode is used for dial-up. Why aggressive mode is used for dial-up? We will see to it when we are going to discuss the packets. Okay, that what is the challenge? Okay, why it is necessary to go with the aggressive mode when we are discussing about dial-up. We will see to that. But let us first start with the main mode. And believe me, if you understand side to side, this will cover your dial-up, this will cover your AD VPN, and this will cover your entire IPSec VPN. Entire thing will be completed just because you know side to side. Focus on to the side to side. If you know side to side, you know all the things. Except SSL VPN, you know all the VPNs there. Now, let us start. Let me, allow me to clear all this. We will start now with the negotiations, okay? See here. Let us take the initiator, okay? One firewall as an initiator, we will take it. Initiator, we will take a firewall, FortiGate 1, okay? I think this is something which is not going to ISP. Let us take another firewall, FortiGate 2, we will call it as a responder. That means someone who is going to respond. Okay, I'm just calling the names. Okay, now, first message, we are trying to establish a VPN, okay? VPN. So now the negotiation is going to happen. Now, why the negotiation is happening? See, the reason behind to perform a negotiation is, or how does a VPN ensures that the communication is secure? See, it's not enough that if your packet is safe, I have encrypted your packet, that means the data is safe. No. VPN gives you a double sense of security. Double sense, not a single sense of security. What do I mean by that? Now let me take an example of this. Let us assume our Prime Minister Modi is about to visit your town. Okay. Let's take it as Bangalore. Okay. So PM Modi is about to visit Bangalore. So he is going to fly from Delhi and to the Bangalore. He has some other meetings as well when he will come to Bangalore, right? So he has to go to a certain places and all to inaugurate something or whatever he wants to. What do you think? The people, the agency who is responsible for his security, the first thing that that agency is going to do is to secure the route through which the PM will be traveling, right? A route will be finalized, that how a PM will reach to a certain destination and how he will be brought back. Yes or no? The route is secure. Once the route is secured, then so let's say, for example, the agency has secured the entire route, that hey, he can go via so-and-so route and it's a safe and sound route. We will have all the arrangements there, not an issue. So can just PM walk and like take a bike and like ride it? Or he can just open, it's like he can just walk it just like a normal person onto that safe route. No, right? Still the PM has to be secure. For him, there is what the car that he's going to use, what are all those agents which seats on sites or like inside the cars and all. There are certain protocols, right? So the package is also getting secure. Now think PM Modi is nothing that data. That's your data, your actual packet. Now you are the in charge. The VPN is in charge to ensure that that packet has to reach to a certain destination and it has to be delivered in a secured manner. No security breaches as well. So first thing the VPN will do what? Is secure the mode of communication, the route, the path through which the packet will travel, that path has to be secure. Mode of communication will be secure. Once the mode of communication is secure, then the package will be secured and will then be sent through that secured mode of communication, right? Now, when the VPN tries to secure the mode of communication, that is nothing other than phase 1. That is what we are calling as phase 1. So phase 1 responsibility, the first phase of the VPN is to ensure that the path of communication or the mode of communication is secure. Once that is established, once that is confirmed that the mode of communication has been secured now, then the next phase starts. That is referred as phase 2, where it is decided that how I will be sending the data, that how my PM is going to travel. Is he going to travel by the air, by the road? If by the road, which car, which barricades, how many cars will be there, how many agents will be placed, what will be the turning points, whatever that is. That is what is decided in phase 2. Same thing with the data as well. How I will be sending the data. That's where your tunnel mode and transport mode comes into place, right? But when I say ES3 encapsulation will be performed, but after all, that is also encrypted. Okay, the entire packet is encrypted. What is that encryption? That is decided. How I am going to send the data is done on the phase 2. So this is what we are going to learn here. We will see how the VPN establishes the phase 1 and henceforth move to the phase 2. What does it do? Okay, so let us start with that. First message that the initiator will send is as a proposal. So how does that message will look like? I'll just draw an overview, okay, to give you an insight. Of course, that will be guided by the negotiation message, or the VPN negotiation messages is always guided by the ISAC header. Okay. So IPSec header will be there, which will carry the assay payload. Under the assay payload, there will be multiple transform payload. Transform, FORM, transform payload. Okay, so like I'm writing transform payload as in this, transform payload 1. Now I'm writing TP, okay, TP2, TP3. That is what I'm writing, okay, transform payload 1, transform payload 2, transform payload 3. That is what it has been sent. First message. I'm going with basics, okay? I will keep on adding further in informations, but let us understand the basics. So this is the first message. Now, what does this first message contains? This contains assay payload. That means when I'm saying assay means security association. Now think as if in this way. Like I like want to negotiate, right? So we are going to negotiate, right? So just like in SSL handshake, the cipher was exchanged, right? Why? To know that, hey, I support so and so ciphers. What do you support? So he will choose out of that and he will respond that, hey, I will choose this and I will support this, right? So they both came to a conclusion that, okay, fine, we are going to use this cipher set. Similar to it, here also in VPN, when the initiator sends a assay payload, what will be that assay payload? That is entirely dependent upon what the configuration that you might have done in your phase 1. So in phase 1, whatever the negotiation parameters that you might have chosen, that is what will be sent. Now here I am saying transform payload. What is that transform payload? The transform payload is nothing but the collection of, okay, where I will go. Come on, I wanted to write that somewhere. Okay, let me go back. Just a moment, please. I have to write that transform payloads and all. The eraser works as if I'm working on a Natraj eraser. I'm not sure if you guys remember a white Natraj eraser, right? That's how the dusting goes on. The effect is really good. Natraj. Okay, see here. See transform payloads, okay? What is that transform payload? What does that contain? Transform payload. It contains parameters like haggle. Okay, haggle. Shortest form to remember it, okay? Remember haggle. Where E stands for encryption. L stands for lifetime. G stands for Diffie-Hellman group. A stands for authentication. And H stands for hash. Clear? These are the 5 parameters which are sent in the transform payload. Now I said transform payload 1, transform payload 2, transform payload 3, right? So that depends. Now for example, you have chosen that, hey, I will be using encryption as AES and lifetime as 8400. Diffie-Hellman group will be 2 and authentication is going to be our PSK and hashing will be our let's say DES. Okay, that is what I'm choosing. And this is much better than it will be. So it's authentication and your hashing. Okay. Now similar to that, I will also say, hey, I can also support AES 128. Lifetime will be 8400. Diffie-Hellman will be 4. Authentication will be PSK only, and hashing is going to be, let's say, DES only, right? So this is one set of proposal, and this is other set of proposal. This is why I'm calling it as transform payload 1, transform payload 2. Clear? Now the other party has to choose whether he wants to go with transform payload 1 or transform payload 2. So he will respond with that. Okay? So coming back to our point, when the initiator sends the assay proposal message, the responder has to respond to it. So he is also going to respond. How he will respond? In the same manner. This response will be carried by the ISACAMP header. Of course, this is the header that carries all your VPN negotiation messages. Okay. He will also contain the assay payload. This is the reply message, under which there will be the chosen transform payload that it has chosen. Okay. So he will choose that. Clear? And this is the reply message that will be received. So I'm calling this message as message number 2. So in first 2 messages, what we have done, we have simply negotiated that what will be the encryption, hashing, authentication, and lifetime, as well as the Diffie-Hellman group that we are going to use for our encryption of the channels and all. That is what we have simply decided. Okay, we should be on the same term, right? It should not be that I can speak Kannada but you cannot. So if I start sending you the Kannada data, you will not be able to make sense, right? You will say that, hey, I don't know what language you are talking about. So we should be on the same page. If you are saying that I understand English, I should also be saying that, yes, I am comfortable with English. Then only we can talk, right? Same thing. Now, saying that, let's go back to message number 3. Once this negotiation is done, chosen, then in message number 3, you have, of course, ISACAMP header will be carrying this information, and here you will have the Diffie-Hellman public key material. Diffie-Hellman public key is been sent actually. Okay, so I'll forget about materials and all. I will write it down. Diffie-Hellman public key. Diffie-Hellman public key. That is what he is going to send. Sent here. Message number 3. The responder will receive this message, Diffie-Hellman public key message. Okay. Similarly, responder will also now fabricate the 4th message. He will also say, okay, fine. I'm also going to send you the Diffie-Hellman public key from my side. Okay, so he's also going to send you the Diffie-Hellman public key. I'm calling it as message number 4. So the key exchange has been performed. Clear? Now, assume I am having now message number 5. Now be mindful, from the message number 5, the actual encryption will start. Okay? Hey, I'm loving to erase it, man. Okay. Loving to erase it. Okay, so see here, the message number 5. Okay. ISACAMP header. And here it will contain the ID payload. ID payload. In the ID payload, what is mentioned? In the ID payload, like which protocol you are using, your IP address and the ports and all. That is mentioned in the ID payload. Okay. Also, there will be a nonce and then there will be a hashing. Hash of what? Hash of the ID payload. Okay, there will be a hashing value. Now please note, all these will be encrypted. Okay, this will be encrypted. This will also be encrypted. Okay, and this encrypted message has been sent to the firewall 2. Firewall 2 will receive this. Since it also knows what is the encryption value that you have chosen in the first two messages, hence it can start decrypting this and it can confirm it that okay fine who you are actually, right? So the ID value, so he will say okay fine, you are the IP so and so, yes, as per my configuration I have to talk to this person only, right? So ID is confirmed. Okay, password match also happens here only. The password and everything is matched here only. Okay, from message number 5 only. Authentication happens in 5 and 6 only. Okay, now, so it will do it. Now, why there is a hash? Hash is there in order to ensure that the packet content has not been altered. Integrity of the packet. Hashing is always there to confirm integrity. I believe I have explained you this, why you need a hashing. Right? When the responder will calculate the hash of this ID payload, it should come exactly same as what has been mentioned here. Okay. So if that's same, that means the content has not been altered. Okay. That's why there is a hash payload in there. Okay. Similar to that, here also, okay, your responder will also be sending. Once it confirms, verifies that, then of course he will also be sending the same thing. Means his own ID payload. He will be sending his own ID payload, which will contain his IP, UDP, and the port that he might be using. Okay, it will contain all that. Then you will have a nonce payload, and then you will have a hashing payload. Okay, then you will have a hash values. Point is, this is going to be the encrypted one. Similarly, this is also going to be the encrypted packets, right? Payloads. Hence, this is what we are calling it as packet number 6. Packet number 6. And this packet is sent to the firewall 1. Same way, firewall 1 will also verify the ID payload and also will calculate the hash value, and that hash value should be exactly the same what it finds in this received packet. If it's the same, it knows that the packet has not been altered and the authentication is successful and all. And if this happens, then it is said that hey, the phase 1 is out. This completes your phase 1. Clear? And this 6 message negotiation is referred as main mode negotiation. Clear? Clear?
Yes.
Now, see here. Once the phase 1 is completed, then the firewall moves to the phase 2. So till now, the mode of communication has been secure. Okay, the mode has been secured. Whatever that they are going to use in order to form the tunnel, okay, that is what has been secured. Nothing less, nothing more. Mode has been established, phase 1. Now, the next part about phase 2, how I will send the data. Phase 2. When the phase 2 starts, okay, when the phase 2 starts, now I am continuing the message from there only, okay, message number 7 now, from the initiator side. Okay, so here, now please note, every message will be sent in the encrypted format. From the message number 5 only, the encryption has started, okay. So henceforth, every message will be sent in the encrypted format. Okay, now it is, of course, it will be guided by the IPSec header. And what all informations it will contain here? What all informations it will contain? It will contain exactly the same information what it contained in message number 1, 3, and 5. So as per phase 1, okay, the information that it contained in message number 1 plus 3 plus 5, it will contain, it will send the similar type of information. The value may change depending upon your phase 2 configuration. Maybe you are sending AES 128. Maybe you are sending a different public key value. Maybe you are sending a different authentications, the keys and all. Okay, but the issues is like you will be sending the same thing. When I say same thing means you will be sending the SA proposal. You will be sending the DeFi Helmet public. Okay, that is what you're going to send. So this is how you have to remember. This will never allow you to forget that. Okay, that what you send in quick mode. Just these packets will be encrypted. That is the only thing you have to ensure. Now, if this is sent, come on, okay. Now, the other side will also respond, message number 8. This will also contain IPSec header. And it will contain the similar kind of an information that you might have sent in 2, 4, and 6. Message of the phase 1, okay. That is what you will be sending. Of course, this message is also be going to be the encrypted message. And then you will have a 9th message, which is nothing but the keep alive message. Keep alive. That is liveliness proof. Okay, that is what has been sent here. Done. Once this is completed, it is said that your phase 2 is completed. Done. And since this involves only 3 messages, hence this type of negotiation is referred as quick mode. Okay, clear? Every message is encrypted in phase 2. That is what the point is. Clear? Before I move further, is it clear?
Yes.
Okay. Fine. Clear. In this IPSec headers and all, okay, here's what you see in the first and second message and all. If in case this was a direct communication, right? There is one more payload that is being sent in the first and second message. What is that payload? That payload is called NAT-T. NAT-T. Okay. Both the see, in order to ensure that the NAT-T is supported, the NAT-T functionality will only work, or the NAT-T feature will only work if both the parties confirms that they support NAT-T. If any of the party says that, hey, I do not support NAT-T, then the NAT-T will not be performed. Now, what is the use of NAT-T? The use of NAT-T is to identify if there is anyone in between you and the destination that you are trying to reach. That is between two firewalls. Is there someone who is in between that? See, why it is important to find out whether there is someone in between Fortinet 1 or Fortinet 2 firewalls or not. Why it is important? Because of two reasons. One primary reason is the phase 2 message, the ESP packets and all. Okay, those are layer 3 headers which do not contain ports. And if there is a NAT device which is configured to do PAT, port address translation, and if it receives such a packet, it will drop that. Right? Yes or no? That will cause an issue, right? Because what the packet you are sending is do not contain any port.
Yes.
The payload do not contain the port. So if such a packet reaches to a PAT device, that will create an issue. First thing to that. Second thing, we are talking about VPN, right? We are boosting that VPN ensures that my data is going in a safest way and no one can see and the mode of communication is good. But how dumb a VPN will look like? Let's say you are thinking, if I am on the FortiGate 1, now I'm going back to this situation now, 5th and 6th. Just think, FortiGate 1 is thinking that I'm talking to FortiGate 2, and FortiGate 2 is thinking he's talking to FortiGate 1, right? FortiGate 2 may be talking to FortiGate 1, but is FortiGate 1 actually talking to FortiGate 2? No, he might be talking to this router, right? His packet is actually going through this router. So it's not a direct communication. Someone is there in between. And if you are not aware of that someone, how you can say that you are really a secured way of communication? You have to be aware of that. Is there someone in between us? If yes, then they will change their behavior. How do they change? The VPN, by default, the IPSec VPN functions on UDP port 500, right? As soon as it identifies that there is a NAT device in between them, this switches from 500 to 4500 port. And how do they do that? First question is, how do the VPN identifies that there is a NAT device in between? The feature which helps the VPN to identify that feature is called NAT-T, where the T stands for traversal. So NAT-T is the feature. Now, once both the parties confirm that they are using NAT-T, then the NAT-D payload is sent. Then in the third message, where you saw that I only send the Diffie-Hellman public key, actually here there will be a nonce payload and NAT-D. There will be two NAT-D payloads actually. Two NAT-D payloads will be sent. The first NAT-D payload is for source IP and source port. The second NAT-D payload is for destination IP and destination port. So NAT-D contains the hash of the source IP and source port. NAT-D, D stands for discovery. Okay, when this reaches to the other side try to match with the hash value. Do you want to see with an example with the packet flow? How do they do that? or what I'm saying that is enough to understand? Do you want me to show you the packet flow? Give me a no.
Yes. Yes.
Okay, fine. Let me show you that. See how does a NAT-D helps. We will take a simplest example. We have a PC, a FortiGate firewall connected to the ISP, connected to a router, connected to FortiGate 2, which is in turn connected to a different PC. Okay. Now let us name the IPs. So this PC1 IP is 192.1. Okay. Now FortiGate, since it is facing the ISP, so this interface IP is 1.1. Okay, we will take it as 1.1. Okay, router is facing to the ISP, right? So this IP is, let's say, 2.2. Okay, we will take it as 2.2. Okay, so that means FortiGate 2 IP will take it as, let's say, we will take it as 172.1, and that means router IP here will also be 172.2, right? Yes or no? Same subnet, tightly connected, and the PC IP is assume it is 10.10. This is the PC IP. Clear? IP standards clear?
Yes.
Okay, now see here. We will assume that the VPN has been formed between, it's like they are trying to form the VPN connection, okay, from the FortiGate 1 to FortiGate 2. That is what they are going to do. FortiGate 1 to FortiGate 2. They are going to form the VPN. So what will happen is, let's say the firewall, okay, the FortiGate 1 is sending the negotiation messages. How it will send? The packet will look like this. And hey, source IP is 1.1, destination IP is 2.2. Because when someone will ask that, hey, I am on FortiGate 1, so if I will configure the VPN, I will ask now, what is my remote peer IP, remote gateway? I have the FortiGate 2 engineer will say what? It is 2.2 public IP. He has to give me a public IP, no?
Yes. Yes.
So I have this packet. Source port 500, destination port 500. Yes or no? Now assume we are talking about message number 3, okay? So here what happens is, since it's IPSec VPN negotiation is going on, so NAT-D payload, okay? So he will calculate the hash of source IP and source port. Okay, so hash of source. So source came as, let's say, SRC. When it calculated the hash using an algorithm called DES. Okay, so he used the algorithm DES for calculation of the hash as per the negotiation that he has performed. So he is using the DES algorithm. Okay, so as per that, if the source is 1.1 and source port is 500, the hash value is calculated as SRC. And if IP is 2.2 and port is 500, then the hash calculated is DST. Okay, so he is giving the hashing value here, DST. Right? Now he's sending this packet to the ISPs. ISP is sending it to the router. Router receives it. Now router will do what? Router has to forward this packet to the FortiGate 2, because after all the VPN is configured on FortiGate 2. Okay. So router will send it further. That means on the router you might have configured the DNAT, right? So
Yes.
let's assume you have configured the DNAT. So router will modify. It's like it will try to translate this packet, right? So it will say that the traffic is coming from 1.1 who wants to reach to 172.1, right? He translated the IP, destination IP. Source port 500, destination port 500. Okay, and of course he cannot modify the hash value. So the hash will still be SRC, and the other hash will be DST, right? This is the packet that is received on the FortiGate 2. Now FortiGate 2 will do what? He will perform the hashing. He knows from the first two messages that the hashing algorithm is this, right? So he will calculate his own hash. He will perform the hash. He will say, okay, let me calculate the hash using the algorithm DES. So what is that source? Source IP is 1.1. And what is that source port? 500. So let me calculate the hash. If the algorithm is same, the hash will come as SRC match. It will say it's a match. Okay, fine, good. Destination IP is 172.1. Destination port is 500. It will calculate the hash. The hash will come as, let's say, something XYZ, because after all it's a different IP, right? So it will never come same, correct? So now it will say, hey, it's not a match. That means Firewall 2 knows that there is someone who is translating the destination, maybe destination IP, maybe destination port, but there is someone who is translating the destination, right? Firewall 2 is now aware of that, yes or no? Yes or no? Because the hash mismatched?
Yes.
Okay. So Firewall 2 has come to aware, or he is now completely sure that there is someone before him who is doing destination map. Okay. So Firewall 2 is aware now. Similar to it, now Firewall 2 will also send a packet in response, message number 4, where he will say that, hey, look, the source IP is one. Okay, I took a very big one. So he will say, look, the source is 172.1 and destination is 1.1, right? IPs. The ports are 500, here also 500, okay? But he will also calculate his own hash. For the source, he says 172.1 and port 500. If we calculate, it will come at XYZ. So XYZ, right? And if he calculates the hash for 1.1 and 500, it will come as SRC. So he will give SRC. Okay, fine. This packet has been sent, reaching to the router here. Router will do what? Again, NAT, he will translate the source. This time the router will do source netting, because he has to send the packet to the internet, right? So he will translate 172.1 IP to 2.2. Destination will remain 1.1. Source port will be 500. Destination port will be 500. He will not be modifying the hash values. So hash value will remain as XYZ, NATD payload, and the other NATD payload will contain the hash value as SRC for the destination IP and destination port. Now this has been sent to the FortiGate 1. Now when FortiGate 1 will receive this, FortiGate 1 will say, okay, fine, let me calculate my own hash. So he will say, okay, the algorithm is DES, right? Okay, fine. So what is the source IP? Source IP is 2.2. What is the source port? Source port is 500. What is the calculation of this? He will come around, he will say, okay, it is like EFG, for example. Similarly, he will calculate for destination is what? 1.1. Destination port is what? 500. So let me calculate this. It will come as SRC. So he will say destination has match, source hash didn't match. That means now Firewall 1 is also aware that there is someone who is translating my source IP or maybe source port. Yes or no? Correct? This is how, when they both are aware, hence from message number 5th, the packet which will be sent will be using the port as 4500. Okay, so coming back to this point. So here when both the parties supports NATD, then the NATD payloads are sent. In the message number 3, similarly here also, he will also be sending the NATD payload. And if they both come to a conclusion that there is someone in between them, then from message number 5th, they will start using port 4500 to communicate. They will not use 500. And henceforth, whatever the communication goes, that will happen on port 4500. Clear? Clear?
Yes.
Okay, fine then. Okay, ma'am. So this is all about IP1. Okay, the main modes and quick mode. Okay, there is one more thing that I wanted to discuss, but I think that everyone is feeling sleepy, so I will not go much into depth. I wanted to go in little more depth with reference to keys, but okay, fine, leave it there. Okay, if we have tomorrow we can think. If you are interested, ask me that. I will be discussing that as well. Okay. Fine. So tomorrow we will be doing the lab. Okay, we will do the configuration and see how we can set up the VPN into the FortiGate firewall. Clear?
Okay.
Okay then. See you all then tomorrow. Thank you. Bye.
Okay. Good night.
Good
Good
night.
night.